Hello everyone. Today we are going to see an interesting topic from class 10 science, that is your light. Light, the properties of light. So when you hear a word light, no, you will have a lot of question. Where do we get light? But without that we cannot survey, right? Okay, but so we need light for our life, right? So it's important to learn what is light and what are the properties of light. Okay, so um, light, can you see this, kids? Light is an electromagnetic ray. So, what is an electromagnetic ray, kids? What is electromagnetic ray? So, if you split this, no, I'm drawing a line. Wait. So, if I'm splitting these two, no, you will have a word electric and a magnetic. So, it is the combination of both electric and magnetic fields. Okay, so what are fields? Where do these fields come? Okay, what is the electric field? What is the magnetic field? Where do these people come? Okay, so what is the electric field? If you keep a charged particle. Okay, if you keep a particle which has a charge, okay, the influence of the charged particle will be felt around the surface. Okay, so that surface, no, you will call that surface as a electric field. Okay, so the same thing for magnets. The same thing for magnets. So when you keep a magnet, no, the space around that magnet in which you can experience a force of attraction, that space is called magnetic field. Okay, in your engage and all, you will play with the magnets. Most oftenly, you will play with the magnets. No? So when you keep a magnet, okay, when you keep a magnet, when you bring any iron particle to go and stuck to the magnet, while when you are bringing closer to the magnet, what happens is that you can experience a pull. The magnet is just pulling that particular object towards that. So that space, you can see that force of attraction, that particular space. So when you take far behind, no, you cannot experience that force of attraction. Okay. So the space around that magnet is called what? Magnetic field. The same thing is only for electric field. Anything which has charges. The same thing only we can experience in electric field. So what is your electromagnetic ray? It is the combination of both your electric and magnetic field. They constitute a electromagnetic ray. So actually these two peoples are perpendicular to each other. I'll just show the figure in the next slide. What is perpendicular actually? You know perpendicular. You people are like far enough than me, right? So you know what is perpendicular. What is perpendicular? Perpendicular is 90 degree. That is the two peoples, these two people. So what are the two people? Electric and magnetic field. These two people are aligned in 90 degree. That is perpendicular. One be like this. If electric field is like this, your magnetic field will be like this. Okay, so that is your electromagnetic ray. So how do these people will travel actually? These people will travel in straight line. Okay, so light is an electromagnetic ray that travels in a straight line. Okay, so this term electromagnetic ray was first coined by Maxwell. So the scientists know, they are very brilliant people. Okay, they could never wait for anything. Okay, so we cannot stop them. They first discovered what is electric charges. Then they discovered what are magnetic things. Okay, so what happens if we merge these two people? Okay, so they keep on discovering things. Okay, so finally they got into the conclusion like light is an electromagnetic ray. That is, it is the combination of electric and magnetic field which are traveling in a straight line perpendicular to each other. Got it? So this is your light. Okay, so this is your light. So from that, no, what we can take is that your reflection of light. What is your reflection of light actually? Reflection of light is nothing but when a light falls on a surface. When a light falls on a surface, that is your reflection. For example, in day-to-day life, you are seeing a mirror. Okay, you are seeing a mirror. So whenever you are going out, you can see your mirror, the reflection of you. Okay, you just try to align yourself, right? You just try to align yourself when you go outside. So that is your reflection. So when a light falls on the surface and is reflected back into the same medium, what is your same medium actually? Your same medium is your air, right? You have air everywhere, right? Okay, so whenever you see your reflection in your mirror, so you go and stand in front of a plain mirror, you see your reflection. So that is the reflection taking place. So whenever a light falls on the surface, the particular surface will just absorb it and then reflect it back. That is called as your reflection of light, kids. Got it? So next is your refraction of light. What is your refraction of light actually? When a light travels from one medium to another medium. What is your another medium actually? So I told you in the reflection of light, one medium is your air. Okay. So what will be the other medium? It may be water or something else actually. Okay. So when a light travels from air to the water, okay, you can see this refraction of light. That is, the light coming and falling into that one medium, it will not be the same. Okay, it just bends from its original path and then it's entered into the other medium, a water. That is called as your refraction of light. So this phenomena is called refraction, kids. Okay, so reflection is nothing but when a light falls on a surface and is reflected back, and refraction of light is nothing but when a light travels from one medium to the another medium. Okay, so now I'll just show you the representation of electromagnetic waves. Okay, so I told you already, that is, this is your electric field oscillation and this is your magnetic field oscillation. See, the both of them are perpendicular to each other. Both of them are perpendicular to each other. And this is the propagation. So I have highlighted the change in electric field oscillation and the magnetic field oscillation in different color states. Okay, so that is your electromagnetic wave. So we saw what is your reflection. We saw what is your refraction. Now there are technical terms in your refraction. We should know these terms. Okay. So first is your incident ray. What is your incident ray actually? The ray of light that falls on the reflecting surface. So the incident light, whatever we are, that is initially we are going to the reflecting surface. No, so that will be your incident light. Okay, so incident ray. Okay, so next is your reflected ray. What is your reflected ray? A ray of light that is sent back from the reflecting surface. So once the incident ray enters the surface and then it reflects back. Right? Okay. Next is your normal ray. What is your normal ray actually? The normal ray is a line at right angle to the reflecting surface and to the point of incidence. I can tell to the reflecting surface and to the point of incidence. That how it will be, no? So consider this as a reflecting surface. Okay, so the point of like your incident ray coming, it touches the reflecting surface and the reflection is going back. Okay, the normal line is the right angle between your reflecting surface and your incident light surface. Okay, so next is your angle of incidence. Angle of incidence. So from the name itself you can get what is your angle of incidence. What is an angle of incidence actually? The light may fall on the reflecting surface at any angle. Okay, you can take 30 degree, you can take 40 degree, you can take 50 degree, it may be anything. So it is the angle made by the incident ray and the normal. So what is the angle of incidence actually? It is the angle made by the incident ray and the normal ray. So that will be your angle of incidence. So got it, kids? So these are the important terms related to refraction of light, and you should know this. What is your incident ray? What is your reflected ray? What is your normal ray? What is your angle of incidence? Got it? So what will be your next thing is we did what is your angle of incidence, angle of reflection, that is your reflection ray, and then your normal line, and then the angle of incidence. Terms related to the refraction of light. Okay, so what is your refraction of light? So the angle of reflection I told you earlier, right? So what will be your angle of reflection? It is the angle made by the reflected ray and the normal line. That is your angle of reflection. So these are the things. See, I told you, no, the other parameters will come into pictures automatically. First one is your object. Okay, so it is a thing that forms an image on the screen. Without that, we cannot do anything, right? So while standing in front of the mirror, I am the object and I can see my image. So object, it is a thing that forms an image on the screen. What is your image? It is the reflection of the object on the screen. That will be your image. Simple terms. Okay. So, you need not memorize at all actually. Okay. So, these are the terms. Once when you get through it, you can write by your own. That is the thing. Okay. Understand and reproduce it. Okay, simple. So the object, it is the thing that forms an image on the screen. And what is your image actually? It is a reflection of the object on the screen. Next important thing is, what is your important thing is virtual image and real image. What is your virtual image? The image that cannot be obtained on the screen. Virtual. So from virtual means a false image. It's not a true image. Okay. A surface where image is formed. Okay. So the image is formed inside the object itself. Okay, you cannot obtain on the screen. That is only virtual image. Got it, kids? Virtual, false image. And we will deal this virtual image like clearly in the upcoming slides. Okay, so what is your virtual image actually? The image that cannot be obtained on a screen. Okay, a surface where image is formed. Okay, real image. What is real image actually? It's a real image of mine. Okay, on the mirror. So what is your real image? The image that is formed directly on the screen. So I can see the real image directly on the screen. That is your real image. Okay, so understood these things. Okay, so you should keep virtual image and real image actually. So virtual image you cannot obtain on a screen. Okay, it is formed on the object surface itself, where the image is formed in object surface itself. So what is your real image actually? The image that is formed directly on the screen. That is formed directly on the screen. Got it? So next is your very important law. This law is, okay, law of reflection of light. What is this? Law of reflection of light. Okay, so law of reflection of light. So I told you, no, incident ray will be like this, a reflected ray will be like this, and your normal line will be in between your incident ray and your reflected ray. This is your plane mirror. That is your normal mirror in your home, whatever you're seeing, right? So what does this law of reflection does? So clearly, they told one thing. That is, take a surface. So whenever a light falls on it, that you take it as a incident light. So it falls on it and you get the reflected thing. And in between these two people's, your incident ray and the reflected ray, you will have a normal line. So what is this normal line actually denoting? Right? Why, ma'am, we need to have a normal line? Right? Why we need to have a normal line? It's incident ray, it's a reflected ray. It's okay. Why we need to have normal line is that how much of an angle of incident ray, whether it may be 30, you have a protector, no. Okay, in the geometry and all you would have used. You will have an angle measurement, 30 degree, 45 degree, 60 degree, it will go on, no? So when you keep like from this slide itself, it may be like a 45. Okay, so how much ever the incident ray is varying when it goes to the reflected ray. For that reason only, you have a normal line. Okay, so what is your law of reflection of light is? So the angle of incident is equal to the angle of reflection. So whatever your incident ray, that is equal to your reflected ray. Okay, so the incident ray, the reflected ray, and the normal to the mirror at a point of incidence all lie in the same plane. Can you see it? Your incident ray is also on the same plane, your reflected ray is also on the same plane, your normal line is also on the same plane. Okay, so the incident ray and the reflected ray lie on the either side of the normal. It's a simple diagram, no? It's a simple diagram. Okay, so whenever a light falls on the surface, you have a incident ray. It reflects back, reflected ray. You have a normal line. All these three peoples meet in the same plane. Okay, got it. Got it. It's clear. So this is your incident ray. This is your reflected ray. And this is your angle of at which it is kept or it falls. The angle of incidence. And this will be your angle of reflection. Got it. Clear, no? Your law of reflection is. So next we are moving to properties of image. So we talked about, okay, how the light falls on a particular surface, then it reflects back. Okay, so what is the thing behind that? Okay, using that property, what we can do. So what are the properties of plane mirror? Whatever we are using in our home, either it may be like hand mirror or a face mirror, like a fully mirror. Okay, so everything. So image formed in a plane mirror is. So how the image will be in the plane mirror? How the image will be in the plane mirror? Okay, that we have to see now. How the image will be in the plane mirror. So virtual and erect. So what is virtual? Virtual and erect. What is erect actually? Virtual, you know. What is virtual? I already told you, false image. That is, the image cannot be found on the screen. Okay, so it may be like it is virtual. And erect is, can you see from this diagram, kids? You have a candle here. Okay, and you're seeing the same candle here, upright, erect. That is called as your erect. So what is an erect actually? It is the right side up image is called an erect image. So what is erect image? The right side up image is called a erect image. So that is your erect image. Okay, so in the optics, an erect image is one that appears to be upright. That is appears to be upright. So in optics, an erect image is one that appears to be upright. You can see very well from the candle. Okay, like from the image in the candle. Okay, so whatever you are placing the object, okay, the object distance, no, from the mirror, the image is also formed like a same thing only. Okay, so whatever you keep the candle, you keep the same candle. Okay, in whatever distance you are keeping, corresponding to the distance only, your image is formed. Okay, so at the same distance from the mirror, as the object is in front of it, you can see an object in the front of it. So this is your plane mirror. you're keeping a candle in front of the plane mirror and you're seeing the same image over here. Okay, what is laterally inverted? What is laterally inverted? So from the name, what is laterally inverted is, lateral inversion is, that is in the mirror, no, whenever you see the mirror, no, when you raise your right hand in the mirror, you can visualize your left hand. Have you ever have you ever experienced that actually? Okay, can you see this letter behind me, happy? Can you see this letter behind me, happy? So when I bring a mirror, no, when I bring a mirror in front of this happy, will the happy be same? You have I know you people will do a lot of experiments, I know that. So when you keep this mirror in front of the happy, what you can do, what you can see is, you will get the lateral inversion of that happy. You cannot see the same happy actually. You can get the lateral inversion of that happy only. You can see the lateral inversion of the happy only. That is only laterally inverted. That is only laterally inverted. Okay, so what are the properties of the image formed by the plane mirror? The image formed by a plane mirror is virtual and erect, so of the same size as the object, at the same distance from the mirror as the object is in front of it, and it is laterally inverted. Got it, kids? You know what is lateral inversion, you know what is erect, okay, you know what is your virtual image. Okay, lateral inversion also I told you. Okay, so another thing I can tell is for your erect image is that when both the rays intersect one another at specific location, an erect image is created. An erect image is created. Can you see the candle? Both rays are intersecting at the specific location. Okay, that is your erect image. That is your what image? Your erect image. Okay, got it, kids? Okay, I told you what is your virtual image actually. Virtual image is the false image you cannot obtain on the screen. Okay, so that is your virtual image. So it's clear for you. It's clear for you the properties of mirror formed by the plane mirror. So next important thing is your from the plane mirror. So your plane mirror is over. Your plane mirror. Next important thing is your spherical mirrors, your concave and convex mirror. Your concave and convex mirror. I'll show you the diagram in the next slide actually. Okay. So your concave and convex mirror. So what is your concave mirror actually? Concave mirror and convex mirror. So in concave mirror, a spherical mirror that has its reflecting surface curved inward. The reflecting surface, no, that is whatever the light comes and fall on the surface, that is called as a reflecting surface. The reflecting surface will be curved inward. How the reflecting surface will be? It will be curved inward. Okay. What will be in your convex mirror? A spherical mirror that has its reflecting surface curved outward. So, in concave mirror, the reflecting surface will be curved inward, and in convex mirror, your reflecting surface will be curved outward. Your reflecting mirror will be curved outward. Got it, kids? So there are some important terms to be explained. First, in terms of spherical mirror. So there are some important terms. So before going into your spherical mirrors, that is your concave and convex spherical mirror, we should know the important things in these mirrors. Okay, so first is your center of curvature, second is your focus, third is your principal axis, fourth is your pole, fifth is your focal length, and sixth is your radius of curvature. Got it, kids? Got it? So, what are these things? We'll see now. I'll show you what is your convex and what is your concave. Okay, so can you see from this picture, whenever a ray passes through your convex, it just what it happens is, it will just converge. Can you see from this point? Two rays are meeting at one point. So converge. Converging lens. So what is your convex lens is otherwise called converging lens. Here can you see in concave? What is in your concave actually? In concave is actually a diverging. The two rays, okay, doesn't meet together. It doesn't meet together. And this is, they appears to meet. Can you see the dotted lines? What is the meaning for the dotted line is they appears to meet actually. They appears to meet actually, but they doesn't meet. Okay. So, yeah, I told you, no, the terms used to explain the spherical mirror, center of curvature, that is represented by the letter C. So, what is your center of curvature? It is the center of the sphere of which the mirror is a part. I'll show you in the next picture. Okay. So, it's a center of the sphere. You know the sphere, no? Have you seen sphere? Okay, so have you seen sphere? The sphere, it's just like a ball. Okay, so it is the center of the sphere of which the mirror is a part. So it is the center of the sphere of which the mirror is a part. What is your radius of curvature? That is represented by the letter CP. It is the radius of the sphere of which the mirror is a part. So it is the radius of the sphere of which the mirror is a part. A radius of the sphere. That will be the center of the sphere. Radius of curvature will be a radius of the sphere. Next thing is your pole. What is your pole? It is the center of a spherical mirror. So it is the center of a spherical mirror. Center of curvature and pole. So it is the center of sphere of which the mirror is a part. Pole is, it is just a center. Center of curvature will be the center of the curvature of the total sphere. Pole will be just the center. Next is your principal axis. It is denoted by the letter XY. Axis. Okay. So it is a straight line passing through the center of curvature and the pole. So it is a straight line which is passing through the center of curvature and the pole. Like, you should remember all these parameters because in next upcoming slide, we are going to learn the ray diagram. And when the light falls on the particular convex or a concave surface, what we are going to see? What will be the impression of your image? Okay, so this is your thing. See. This is your convex mirror. Can you see it? Can you see it? This will be what? This lines will be what? Your reflecting surface. Your reflecting surface is a hollow sphere of glass. Okay, so this is your convex mirror, and this X and Y will be your principal axis, and the center point of the principal axis will be your pole. Okay, so this will be your radius of curvature. Can you see it, kids? This will be your radius of curvature. This is the center of curvature within the sphere. And the same thing, but the reflecting surface will be opposites. What did I told you before? In convex mirror, it will be like your reflecting surface will be curved inward. Can you see this? But in concave, it will be curved outward. Okay. So here also the same thing. So your concave mirror, and this will be your pole, like the center point of your spherical mirror. This will be your center of curvature, and this will be your, okay, my video has just like it is not show like your thing is not shown. Your radius of curvature will be here. Okay, so it's simple diagram. Okay, so next is your, yeah, so the focus. So focus and focal length of a spherical mirrors. So what will be your focus and focal length of a spherical mirror will be? So principal focus. We talked about your principal axis. Now it is principal focus. Okay, so it is a point on the principal axis where all the rays parallel to the principal axis converge. parallel to the principal axis will converge. That is, if you can see from this diagram, no, this is your concave mirror. These are the parallel rays. See, this will be your principal axis. Can you see? This will be your principal axis. So when the rays parallel to the principal axis, it goes and strikes on this concave mirror. What happens is they just reflect back, and in the focus, they just concentrate on the focus point. Okay, so it is a point on the principal axis where all the ray parallel to the principal axis converge. Can you see? Converge. Okay, so that is called as a focus of concave mirror. That is where all the rays are coming and concentrating in one single point. That is called as a focus of concave mirror. That is called the focus of a concave mirror. What will be your focus of convex mirror? The same thing. In convex mirror, if you can see the same parallel ray, it goes, strikes the mirror, and you can see the reflected ray back. Okay, so it is a point on the principal axis where the reflected ray appears to converge. Here you cannot see the dotted lines. Can you see the dotted lines here? You cannot see the dotted lines here, but you can see the dotted lines here. What is this dotted lines specify is that they appear to converge. They are not converging. They are appear to converge. Okay, so that is your principal focus. Is the principal focus clear for you? The focus of concave mirror, it is a point on the principal axis where all the ray parallel to the principal axis converge. Where all the ray parallel to the principal axis will converge. Okay, so what is the focus of convex mirror actually? It is a point on the principal axis where the reflected ray appears to converge. Can you see the difference between the two? Okay. Next important thing is focal length of spherical mirror. What is the focal length of spherical mirror is that it is a very important thing, and you have a problems based on this. Okay. So what is your focal length of spherical mirror is that the distance between the pole. So the distance between the pole and the principal focus is called the focal length of a spherical mirror. So what is your focal length? So the distance between the pole. Can you see the pole here? Okay, this is your pole and the principal focus. That is your P and F. Can you see? That is the distance between the P and F is called the focal length of a spherical mirror. What is the focal length of the spherical mirror? The distance between the pole and the principal focus is called the focal length of the spherical mirror. Okay, so clear what is your focal length? It's nothing but distance between the underlying thing. Can you see the focal length and the pole? What is your radius of curvature is actually radius of curvature. What will be your radius of curvature? In the before diagram I have shown you. Okay, so the radius of curvature, can you see from here? Okay, so the radius of curvature is 2 times of its focal length. What is your radius of curvature actually? This is your radius of curvature. No, radius of how the radius of curvature and the focal length are denoted by. So the radius of curvature and the focal length are denoted by 2 times the focal length. That is your C is equal to 2F. C is equal to 2F. That is your radius of curvature is nothing but 2 times of its focal length. Got it, kids? What is your principal focus? Okay. Next is your rules for reflection of light. Or rules for what? Reflection of light through spherical mirrors. So just now we saw like so many subdivisions. We saw so many parameters. Keeping all that in your mind, we are going to see rules for reflection of light through a spherical mirror. So there are certain rules you have to stick together. So whenever a light falls on a concave or a convex mirror, depending upon the location, you have a corresponding image of time. How the image will be? Okay. See, for example, if in a concave mirror, a ray of light parallel to the principal axis, that is, Here can you see, this is only your principal axis, this line, the center line is only the principal axis. So what is your parallel ray? One ray will be here, the other ray will be here. So both rays are parallel. You can tell both rays are parallel. Okay. So if in a concave mirror, a ray of light parallel to the principal axis. So can you see parallel to the principal axis, what happens is that it goes and strikes the concave mirror. Okay, which goes and strikes the concave mirror, and the reflected ray is just passing through the focus. We have already seen in the principal focus in the before slide, no? Focus. So this will be your incident and the reflected thing will be your R. Got it? And the normal line will be the dotted lines represent to the center of curvature. Okay, so what does this actually denote? So if in a concave mirror, a ray of light parallel to the principal axis after reflection will pass to the focus. So after reflection, it is passing through the focus or appear to diverge from the focus. In case of what? Convex mirror. Here you can see. So a ray parallel to the reflected ray is just passing through the reflected ray is just passing through the focus. But in convex mirror, the same ray parallel to the principal axis, what happens is that these dotted lines denote they appears to diverge from the focus. They appears to diverge from the focus. Okay, so that is the difference between your concave mirror and the difference between your convex mirror. So it appears to diverge. Okay, so this is your first rule. So what is your first rule? Whenever a ray parallel to the principal axis, the reflected ray will pass through the focus. Okay, but in the convex mirror, they appear to diverge from the focus. A ray passing through the focus. So what will be your second rule actually? First rule is whenever a ray parallel to the principal axis. Next is a ray passing through the focus of a concave mirror after reflection. Can you see this? A ray. This is a ray. Where the ray is passing, it is passing through the focus F. It is passing through the focus F. Okay, so after reflection will emerge a parallel to the principal axis. There, the reflection ray travels through your focus. Okay, here what happens is that it just passed to the focus. It led the reflected ray. But the reflected ray is how? Can you see it? Can you tell me? The reflected ray is parallel to the principal axis. Will emerge parallel to the principal axis. It's just opposite of your rule 1. Parallel, the incident ray is parallel, it passes to the focus. Yeah, when the incident ray passes to the focus, it emerges a parallel reflected ray. But what happens in the convex mirror actually? What happens in the convex mirror? In the convex mirror also, it's the same thing, but it appears to pass through. It appears to pass through. Got it? Next, what will be the third rule? So, a ray passing through the center of curvature after reflection is reflected back along the same path. So, what can you tell from this? So, whenever, can you see, this is your center of curvature, no? So, whenever a ray traveling through the center of curvature, after reflection, it is reflected back. Can you see this aroma? See? It is reflected back. Okay, so it is reflected back along the same path. Here also, but it appears to do so. But it appears to do so. So whenever a ray passing through the center of curvature after reflection is reflected back along the same path. And what can you tell about a ray incident obliquely? What is obliquely? What is obliquely? A little like a obliquely means slanting. Okay, a ray incident obliquely to the principal axis. Can you see? It's slanting, not a straight thing. So when the ray is obliquely, incident ray is obliquely to the principal axis towards the pole. This is your pole, no? We saw in the previous slide and all. is reflected ray is also obliqual, slantingly. Okay, so whenever an incident ray is obliquely on the pole, the resultant reflecting ray is also obliqual. In convex mirror, it appears to be. Can you see? In convex mirror, it appears to be. Got it? So these are the 4 rules of reflection. So we know the 4 rules of reflection. What is this is formation of different types of images by concave mirror. That is, you have a mirror. In what position, if you keep the object, what about the position of your image? That's it. Those 4 are rules. These are the, with respect to your position, okay, with respect to your object position, where you'll get the image position, So we can place the object at 6 positions from the mirror. One is at infinity, behind C, at C, between C and F, at F, between F and P. Between F and P. Okay. Okay, kids, up to this clear? Okay. So we saw what is light, or what are the properties of light, laws of reflection. Next, we saw your plane mirror. Next, we saw your concave and convex, and rules governing your concave and convex. Okay. Okay. So this 6 position, no, we'll see in our next lecture, upcoming lecture. Okay. Thank you.